couple slides of Monday's class. So pull out those at 6-4 rational exponents and go to the second purple page. I know I just told you that. So we've already done the first half of this page. Go to the second half where we just did one of these. So, and actually to help you all with the homework, the difference with what we're going to do now compared to what you do in your homework is these first examples we were just rewriting. And that's what most of your homework was just rewriting. What actually should be written above this next line is now we're simplifying. So when the directions say simplify, it means you want to get down to a number, if possible, okay? Or take it as far as you can. Whereas on the rewriting, you didn't have to actually take it to a final answer. You just had to rewrite it, okay? So that's kind of the difference. So on this, we started this last class, and I kind of use this as an example of why we do radicals and exponents, because you could solve this because they're like bases, they're being multiplied, right? We talked about how you could solve it by just adding the exponents, and your answer is 5 to the first, okay? The other way to do it is, and the way we have to do it for these next couple examples, is you could rewrite it into radicals, go back to radicals, and say radical 5 times radical 5 is radical 25 is 5. Okay, so either method of these would work on that. Now, when you don't have like bases, then, and you've got fractional exponents, then you really do need to put it back into radicals. So this one we would say fourth root of 5 times fourth root of 125. So now when we multiply radicals, what do? Because the indexes are the same, we can multiply what's inside, right? So 5 times 125 is going to be 625. Then to find the fourth root of 625, we break it down, right? Now, because it breaks down perfectly, I'm going to take this opportunity to review on the calculator, okay? So again, you can always try it on the calculator, and if you get an integer, you can use that answer. So for this one, just to kind of look it over again, you would go to Math, go to option 5, and then back arrow, and change the index to 4. Then type in 625, hit enter, and it's 5. Okay, so we could have broken it down. It's just you'll be breaking down things here in a second, and we'll take the easy way out on this one. So the calculator tells us that the fourth root is 5.
Even the calculator on our laptops can do that too.
Oh, really? Okay. So no excuse. All right. So this next one, again, different bases. So we really don't want to use the exponent rules. So we can rewrite it as radicals. So radical 3 times radical 12 is radical what?
36.
36. And then radical 36?
46.
Right. Okay, so this is what the first part of your homework, this kind of thing is page 386, 10 through 18 even. Okay? All right. Now, the next, we're going to look at other properties of exponents. So this is just properties of exponents, and this just, I've talked about this already. The beauty of all of this, or the usefulness of all of it, is the fact that you can, when you change the radicals to exponents, all of the properties that we've already learned apply. So this is kind of an example of all those properties. Whereas if you're multiplying like bases, you add, power to a power, you multiply. You can distribute the power. Negative powers, you just bring it down. So all of these properties we've already looked at. We just didn't use fractions. So this is all examples of how you can do it using fractions. Okay? Same stuff applies. So you might just have to add fractions, multiply fractions, etc. So, for example, this first one is power to power, right? So, again, using exponent rules, we're just going to basically, distribute that 3, that power. So first we think of that as 2 to the first, so it becomes 2 to the third, which is what? to the third is 8, right? So now we're going to distribute x to the 1/3, or take x to the 1/3 to the 3 power. So we're basically multiplying exponents. So remember, when you're multiplying fractions, you don't need a common denominator, right? You just multiply top, multiply bottom. So 1/3 times 3 becomes 3/3, right? Which becomes 1.
I like that.
So it becomes x. And then y to the second, taken to the 3rd power, we multiply, we get y to the 6. Okay? So, no, that's not fair. And we're not going too far into this, but you get the concept. So now we're going to distribute this 1/2 power. Okay, so we can use the exponent rules for the variables, okay? But think about when you take 4 to the 1/2 power, that's really just saying what? 2, because what?
It was 1/2 of 4.
No, boo. I mean, that's true, but that's not what I wanted.
4 squared is.
Right. This is, and that's what I was afraid of. I really should make this like a 9, because it is 2, but it's not because 2. It's not because 4 divided by 2 is 2. It's because the square root of 4 is 2. Does that make sense? That should not be a 4.
Okay, so if there's a fraction, you basically divide it.
No, that's not what I'm saying. I'm saying that this is a fraction. It's the opposite of that. It's, okay, so actually, let's do this. I'm going to change this. Sorry. Change this 4 to a 9. Okay, just change the whole problem to 9. Okay?
And why are you changing it to 9?
Because 4 to the 1/2, the square root is the same as dividing it by 2. So when you come up with 2, I don't know if you're coming up with it because you just did 4 times 1/2, which is wrong, or because you took the square root. Okay? So that's why I'm changing it to 9.
So would it be 3?
It's going to be 3, right? Because 9 to the 1/2, again, this is not 9 times 1/2. It's saying the square root of 9 is 3.
Does that read 2 square root 9? Like, is that how you write that?
2.
Because 2 is your index.
Yes,
That would go
but
out.
you don't have to write a 2 on your index.
Yeah.
Right, yeah.
Gotcha.
Yeah, but so the main thing I'm losing you all here on is that exponent of 1/2 means square root, okay? So when I'm distributing this, I'm taking the square root of 9 is 3, okay? Now, ladies be quiet. On a variable with an index, you can use our multiplication rule, right? Because we're taking 6 times 1/2 is 3, right? So this becomes b to the 3rd.
So on C,
C is going to be 5 times 1/2, which is 5 halves,
that's perfect.
and that's all we can get.
You take the exponent, you take the square root of 4, and that's an exponent?
That's a good one. No, I changed it to a 9. I changed the whole problem to just be a 9 instead of a 4. Okay?
4 doesn't exist anymore.
4 is gone. I read 4 out the window. No. And the reason I did is because 4 times 1/2 is the same as 4 is the square root of 4. So when you write a 2 here, I don't know if it's because you did the right thing or because it just so happens that 4 times 1/2 is 2. All right. So this way, if you put 9 halves here, I would know you were wrong. You're doing the right thing. So the main point here is that something to the 1/2 is what's the square root of it? It means square root. Totally blowing this. Okay. All right.
It's okay, Miss Curtis, we still like you.
No, thank you. Not some days better than others. Okay. So now this last one is like basis, right? Different exponents, so we can use the rule about adding exponents. So if we add 1/2 plus 3 halves, what do we get?
4 halves.
4 halves.
2.
Right, or 2. So the answer here is exponent.
As you're adding them, okay.
Right, because like basis, we can use the exponent rule about adding exponents. And
I
when you
was
add
just
fractions,
still a parentheses and like, yeah.
when you add fractions, you keep the common denominator. Okay, now you guys try these next 3. Put a parentheses around this one. And try those. Okay, so let's look at this. So again, same rules apply even though they're fractions. So power to power, 1/2, so you take, 1/2 times 2 is what? 1. So answer is x. Okay? And then again, power to power, we are multiplying, exponents, distributing. 3. There's another stupid 4 in there. So 2 squared is 4, right? X to the 3/2 times 2 is what? 6 over
3, sorry.
Right. It's 6 over 2, right, or 3. So it becomes x to the 3rd. Yeah. And then y to the 4th taken to the second power is y to the 8, right? Okay. All right, now this one, and it's all taken to the 1/2. So again, the main thing that really the whole point of this whole section, and the most useful part of it, is knowing what taken to the 1/2 power means, right? And here again, it's 4. So 4 to the 1/2 is not, it's just saying what is square root of 4, which is 2. Square root of 2, square root of x squared is x. Or again, you can apply the whole rule about 2 times 1/2, 2 to 1. And then square root of 9 is 2. Okay? Alright. Now the last one is just, again, we kind of already did this in homework, but we're doing it again. So y to the negative 3/2, again, the negative means we're going to take it down below. But let's turn 3/2 into a fraction.
It was 2/7, or, no, 7 over 2.
7 why? How'd you get there?
Calculator.
Oh, okay. Not quite what I was looking for. It's one way to do it. The other way to think about it is 3.5 can be written as 3 1/2, right?
Yes.
Well, I'd like you to know how to do it. So 3 1/2.
2 times 3 is 6, add 1 is 7.
There you go. 7 1/2. Okay?
Oh, you can do that. That's great.
Well, you need to know how to do this just for
3 times 2 is 6.
Just for what?
3 times 2 is 6, plus 1 is 7, so it becomes 7 over 2.
Well, I already know that one.
No, I'm like, so, like, why do you even do like 3? 1, 2. Because it's like 5 is equivalent to 1/2.
I'm trying to convert 3.5 into a fraction. So one way to think about it is 3.5 is really 3 1/2.
Yeah.
And then 3 1/2, 3 times 2 is 6, plus 1 is 7, 7. Or plug it in your calculator and hit what frac.
I don't see why kids do that, because they're always going to have a calculator on.
You're not always, right, but what, anyway, you're not
On our
always
phones.
going to have a calculator.
Our phones are always going to have a calculator.
What's that?
What if the subjects you magically have to use this in life?
That's right, you never know.
I love Jeopardy.
Yeah.
I'm not going on Jeopardy.
Okay, so anyway, everybody good with this one? Okay. Now, next one, so x to the negative 2/3, again, that just means first take it down below. And then, and actually someone in the other class mentioned that when I take it to this step, I'm actually leaving a radical on the bottom, which you're not supposed to. So, so we'll stop right there. That way we don't. Okay?
But I was a little bit confused because, like, the point.
All right, so we're not going to cover the last section.
Woo!
Okay,
So we're gonna have free time.
No. No. So we're going to start a review packet.
I love this.
And so instead of, this is not the test review yet, but this is just kind of reviewing the radicals and stuff. No, I did all of this yesterday too with my juniors. So it's just starting the review process, but it's going back to just simplifying radicals, multiplying radicals, that kind of stuff. Okay? So I'm going to hand out this packet, and what I want you to do is choose 6 on each page to do. Okay? Some pages have 8, some pages only have 6, some have 10. You just need to choose 6 per page to work on. Okay? And sophomores, you'll have to do that too. It'll be in the homework box. Okay, actually, sophomores, it will be optional for you guys, but the packets will be in the homework box of 107. Yeah, you can thank Hannah and Olivia for making it optional.